We have our lighting control and we have our shades. So those are two other pieces of the room that we want to establish some sort of control over, right? But we're not going to do it the same way we have been.
Wait, what? Are you saying that not every device in the world should be controlled the same way? How dare you, sir?
Shocking.
What if we don't have a plugin that is useful? If there's no user component that really works in this case, we need to use something else. And here, at least with the lights, we're going to use command buttons. So I'm going to search for command buttons. And I'll drag that in right here. All right, let's open up that component, take a look at what we have. Now, let's say our lights in this case are controlled over the network, and we can take the command buttons, take the string fields here, put whatever string commands that would control the different options for the lights, and then send those string commands over the network to the device to then control those pieces. If I jump into emulation mode, I can start filling out everything that I might need in this case. Now, we actually have directions over here in this lighting API box. Really good lighting TCP controller is located at 127.0.0.1 and port 5103. So we can go ahead and input that information. Okay, so now we have the IP address set correctly and we have the port set correctly. Perfect. Now, the rest of it can be a little tricky. We need to establish whatever the string command is for the device that you're working with. In this case, they've let us know we have a set level and then :XX for whatever level of that light control we want. So we'll put that right here into the string fields, set level, and we'll give them 4 different options. Let's give them the highest all the way down to the lowest, being off. So I'll start with set level 99.
While he adds those in, let's talk about that XX really quickly, right? In that description, it says it's looking for XX. That's a 2-character number. If you just put in a single digit, like if you put in 9, that doesn't fulfill what the device is looking for. So when it says XX, that's a kind of a hint that the device needs a 09 or a 01 for those, those single-digit numbers. And that also means that it's not going to accept 100 or higher because it's not asking for XXX. So sometimes you kind of got to snoop around in the manufacturer to find out what it is they'll actually accept on your end.
Yeah, and if you include XXX, Vin Diesel appears.
It's like saying Bloody Mary into the mirror.
Yeah.
That's terrifying.
Okay, this isn't complete though. This is something that can trick up a lot of people. You put in the right string, but if I press these buttons, it's still not going to work. That's because something very important is missing, which is the carriage return.
The carriage return? What is that?
That means no more cars, only carriages.
If you look at that lighting API, it says EOL equals \R. That stands for end of line. It says that every time it wants to finalize a string that you're sending back and forth, it must be finalized with the characters \R. That stands for a carriage return in Lua. But there are other ways of representing carriage returns in other languages. So in this case, we were lucky that they told us \R. But just be aware that most languages do require some kind of sign-off, whether that's a new line or a carriage return or something like that. And you may need to hunt in their manuals to find out what that is.
But there's something about this that I'm not quite a fan of when trying to just throw these trigger buttons onto the UCI. The thing about trigger buttons, if you remember, if you press it and you release it, it just kind of lights up and then it's off again, because again, there's no toggling effect to it. What that means is those buttons on the UCI, when somebody presses them and they release it, it'll turn those lights to whatever setting they wanted it at, but the UCI won't necessarily show them which one is currently selected. So let's go ahead and change that. We're not going to use these trigger buttons directly. Instead, I'll jump back out of emulation mode, and I'm going to do something that we did back at the beginning of class. I'm going to steal from some selectors. So I'll grab a selector, drag that in, and now I will expose the trigger for my 4 commands. And then for the selector, I will expose selector 1, 2, and 3, and 4. And connect them across. And now these 4 buttons are interlocking, and I can use them to throw on the UCI. So let's go ahead and do that.
Now, while he does that, here's something really important to keep in mind about command buttons is that they are one-way communication, right? We are sending that string to the device, but we are not getting any feedback from the device as to whether or not it received it. Now, this is fine in a lot of cases. For something like this where we're in the room and there is a physical change, like the lights have literally changed, well, that's your feedback that you successfully contacted the device, right? Or if you see the shades lowering, you know that it worked. And that's one of the reasons why we gave you this emulator, so you could get that visual feedback. But at the same time, in a room like this, there's probably a physical lighting controller on the wall from the actual manufacturer. And a human could walk up to that and hit lights on, lights off. That information is not coming back to our UCI. Right? Our UCI is just these buttons that are just going out. It's not anything coming in. So now our UCI would not actually represent the state of the room itself. So if you need two-way communication, that's when we're going to get into the world of coding. So that's one of the things that we cover in the intermediate and the advanced class, is how to get communication coming back from the device, which we can then use to update the buttons on our UCI so that the UCI is always reflective of what's actually happening in the room.